Good day. So now, let's proceed to our last chapter, chapter 12, the design analysis of single-factor experiment. First, let's have an example for the completely randomized single-factor experiment. A manufacturer of paper used for making grocery bags is interested in improving the tensile strength of the product. The product engineering thinks that tensile strength is a function of the hardwood concentration in the pulp, and that the range of hardwood concentration of practical interest is between 5 and 20%. A team of engineers responsible for the study decides to investigate 4 levels of hardwood concentration: 5%, 10%, 15%, and 20%. They decide to make up 6 test specimens at each concentration level using a pilot plant. All 24 specimens are tested on a laboratory tensile tester in random order. So, as shown dito sa baba, we have here the table for the tensile strength paper, where under the hardwood concentration we have by 5%, 10%, 15%, and 20%. And makikita natin dito sa observations na meron tayong 1 to 20. So, in total, let's i-add lang tong 6 dito. So, sa 5% hardwood concentration, we have the total of 60. So, 10%, 94, 15%, 102, and 20%, 127. And in total of this, tong apat, we will get 383. And for the average, makukuha natin sa 5% hardwood concentration is 10. For 10%, 15.67, 15%, 17, and 20%, 21.17, and have a total of 15.96. So next proceed. So let's proceed to this graph. So we have here the figure A, where ito yung box plot ng hardwood concentration data. So makikita natin dito sa lower part ng ating graph na merong hardwood na nakalagay yung hardwood concentration 5, 10, 15, 20, and the left side is the tensile strength. And dito sa figure B, makikita natin yung model ng completely randomized single factor experiment. Next is the analysis of variance. We may describe the observation in table 13-2 by the linear statistical model. So, makikita natin dito. Ito yung formula for linear statistical model, where y sub ij is a random variable denoting the ij observation is a parameter common to all treatments called the overall mean. I is a parameter associated with the ith treatment called the ith treatment effect, and ij is a random error component. And for our table 13.2, typical data for a single factor experiment under treatment, makikita natin dito 1, 2 hanggang sa A to A for the observation, ito the total and the average. Now let's hear Mr. Talana for the next slide.
Thank you, Mr. Suarez. Now let's talk about the fixed effects model. In the fixed effects model, the treatment effects T sub I are usually defined as deviation from overall mean mu, so that the summation of A, where I is equals to 1, T sub I is equals to 0. Also, we have this formula for the fixed effects model. Now let's proceed to the computing formulas for ANOVA single factor with equal sample sizes. The sums of squares computing formulas for the ANOVA with equal sample sizes in each treatment are sum of square total is equals to summation of a where I is equals to 1, summation of n where j is equals to 1, multiplied by y squared sub ij minus y squared all over by n, and the sum of squares treatment is equals to summation of a where I is equals to 1 multiplied by y squared sub I over n minus y squared all over by n. The error of sum of square is obtained by subtraction, as summation of square error is equals to summation of square total minus summation of square treatment. Now let's talk about the table 13-3, the analysis of variance for a single factor experiment. Fixed effects model. Source, where under the source of variation we have a treatments, error, and total. Under the sum of squares we have a sum of square treatments, sum of square error, and sum of squares total. Under the degree of freedom we have a minus 1 in the treatments, a multiplied by n minus 1 in the error, and an minus 1 in the total. In mean square we have the mean square treatments in treatments, and lastly we have the mean square error. Under the f sub o we have the mean square treatments divided by mean square of error in the treatments. To better understand this topic, let's have some example. Our example for this topic is the tensile strength ANOVA. We can use the analysis of variance to test the hypothesis that different hardwood concentrations do not affect the mean tensile strength of the paper. The hypotheses are, so we have the hypothesis, which is the null hypothesis, is T sub 1 is equals to T sub 2 is equals to T sub 3 is equals to T sub 4 is equals to 0, while the alternative hypothesis we have T sub 1 is not equal to 0 for at least one I. We will use a significant level 0.01. The sums of square for the analysis of variance are computed from equations 13-8, 13-9, and 13-10 as the follows. So ito ang ating solution for tensile strength ANOVA. So through plugging in the given into formula, makukuha natin ang value ng sum of square total, which is 512.96. Same process with the sum of square treatments. By plugging in into formula, makukuha ating value is 382.79. So sa pagkuha ng sum of square error is kailangan lang natin i-subtract ang value ng sum of square total to sum of square treatment, which is ang value ng sum of square total is 512.96 minus the value of sum of square treatments, which is 382.79. So ang overall ang value natin ng sum of square error is equals to 130.17. So that ends our lecture for the chapter 12. Sana may natutunan kayo. Thank you.